Hello everyone. So I hope you all are fine. So today I am going to discuss how to calculate the potential in the concentric shell. So before going to understand this, what we'll do, we'll try to understand some key points, and after understanding the key points, then we'll understand how to calculate the potential in the concentric shell. So I have divided this video into the two parts. Okay, in the first part I will tell you some key points, and in the second part I'm going to tell you I'll discuss how to calculate the potential in the concentric shell. So let's start. Okay, now say look at here, I have considered a shell. Okay, we are having a spherical shell. एक होलो स्फीयर है हमारे पास, हमने उसके ऊपर चार्जेस को डिस्ट्रीब्यूट कर दिया. ठीक हो गया. सो दीज आर द प्लस क्यू चार्जेस डिस्ट्रीब्यूटेड ऑन द सरफेस ऑफ द होलो स्फीयर, एंड लेट अस कंसिडर द रेडियस ऑफ दिस होलो स्फीयर एज a. Okay, so what here I want to tell you, the potential on the surface of this shell will be equal to the potential at any point inside the shell. जो potential इस shell के surface पे होगा, और अगर आप कोई भी एक point अगर shell के अंदर मानते हैं तो उस पर भी वही potential होगा जो उसके surface पे होगा. So this is a very important point. Whatever be the potential, whatever is the potential on the surface of the spherical shell, the potential will be same inside the shell. Any point you consider inside the shell, the potential will be the same. Okay, so I will prove this how it is possible. So for this we have considered the 2 point. One point we have considered on the shell, and the other point we have considered inside the shell. Okay, and we are going to calculate the potential difference between these 2 points. And in order to calculate the potential difference, we have the formula E equals to dV by dr. So E of PQ is equal to dV of PQ upon D of R. Okay, so here we have written the electric field as 0, because we know that the electric field inside the spherical shell is 0, because charge is distributed on the surface of a sphere. There is no charge inside the shell, so the electric field inside the shell is 0. So here we'll put 0. So what we'll get, dVPQ equals to 0, and the potential difference we can write as Vp minus Vq equals to 0, or we can say that Vp equals to Vq. So what we have seen, that the potential at a point P, that is Vp, is equal to the potential at a point Q, that is Vq. So this is a very important point, okay, in order to understand how to calculate the potential in the concentric shell. So you should know whatever is the potential on the surface of a spherical shell, that will be the potential inside the shell. Any point you considered inside shell, the potential will be same. Whatever is the potential on the surface, that will be the potential inside the shell. Okay, so this is a very important point. So if we consider the potential on the surface of the shell, now I have written here the potential on the surface of the shell is 1 upon 4 pi epsilon naught Q by A, and this potential will be equal to the potential inside the shell. Okay, now if we consider any point outside the shell, suppose here this is a P point and this is a distance R, and suppose we draw a Gaussian surface here. So at outside point the potential will be 1 upon 4 pi epsilon naught Q by R. This is the potential at any point outside the shell. Okay, so this is a very important point to understand the potential in the concentric shell. So I hope you all understand it very well. So stay tuned. In the second part I am going to discuss how to calculate the potential in the concentric shell. Thank you so much.